Hey guys, welcome to this session on how can a non-technical person become data scientist by Intellipaat. Data science is one of the hottest job opportunities right now. However, becoming a data scientist is something that is considered to be a really difficult task. Because of that, many people don't even try to understand what data science is and how it can help you significantly in your current profession. Data science is everywhere. Data science basically works on data and allows you to extract insights out of the data. Now, if you know a little bit of data science or are on your way to learn data science, then that could be really beneficial for the job that you are doing right now. Any job that you're performing needs access to some kind of data, and you can turn that data into some sort of an insight, some information which can help you guide your company or your product's future decisions. Keeping that in mind, we've come up with this session to help you get started as a data scientist, even if you're a non-technical person. In this session, we'll assume that you have no technical background. You have access to a system such as a laptop or a desktop or whatever. However, you don't know how to write code. You don't know how to understand the data science technologies that are available for you to use. And with that, we'll help you guide through all of these things and we'll teach you a learning path that can help you learn these things. Let's get started with that. But before we do, we'd like to ask you to subscribe to our channel and click on the notification bell icon to never miss another update. Also click on the like button if you like the video, and in the comment section down below, please put down any further topics that you would like for us to cover in future. Also, if you would like access to this presentation, you can mention it in the comment section below. Our team will reach out to you and help you get that. The code samples can also be made available in case there are any, and you can ask for that in the comment section below as well. Now let's take a look at the agenda to see what we'll be covering in this session. We will begin by taking a look at what is data science. Since that is the thing that we are going to be covering, we need to firstly make sure that we understand and that we are all on the same page in understanding what is data science. Then we'll take a look at companies that are hiring data scientists. This is to show you that data science is not just some off field right now. Many companies regarding that deal with different kinds of products deal with data science. So it's not just something that only tech companies are using, but many companies, maybe government organizations, and a whole wide spectrum of people are using data science. Then we'll take a look at the skills in data science. This is especially important when we're trying to understand how you can get started with data science. Before getting started with data science, you do need to understand what are the things that you can learn in data science in order to become proficient data scientist. Now, these skills vary a lot, and there's a lot of variation in the skills. This is exactly what we'll try and demystify for you. After we are done with the skills and understood what are the skills that are needed to become a professional data scientist, we'll guide you through a learning path through which you can learn these things. Now, at the end of the presentation, we'll guide you through some of the resources that can help you out to learn these things. And right at the end of the presentation, we'll also tell you about how you can acquire the skills that we have thus far mentioned. Any questions that you have during the entire presentation, please put them into the chat box. Our team is there to help you out if and when they can. With whatever question that you might have regarding the technologies that we're covering, regarding the tools that we're covering, or any other question regarding data science, you can ask in the chat box and our team is there to help you out every step of the way. So let's take a look at what is data science. Now, data science is field in computer science that makes use of scientific and mathematical processes and algorithms to extract insight from large volumes of data. As the name suggests, data science is the science that deals with data. It's a field of computer science that, or you can call it a subfield of computer science, because computer science itself is a field and it takes care of extracting information out of data. Now, the difference between information and data is that data is just raw numbers, statistics. You can take a look at them and you can see what's inside the data. However, to have it make some sense, for it to be useful to us, we have to convert it into an information. To give you an example, if I were to show you a list of numbers that represent the prices of stock from the last year to this year, or you can say for an entire financial year, they are just going to be numbers. You're not going to be able to make much sense of those. However, if you wish to learn more about this, what you can do is you can take a look at all the numbers and try and figure out whether or not the stock prices have, on an overall average, have they increased or have they decreased. So that would be an information. It would be an information to know, okay, so from the last financial year to current financial year, our sales have dropped. and the drop has been significant, or has it been negligent, or has there been a rise in the number of profits that we have made? Has it been significant, or has it been negligent? So this is what the information, how you can use and extract information from data is. Now, just because you can extract information from data doesn't necessarily mean that you can extract the information from any kind of data. You need to be selective with that as well. And this is where data science comes into play. When you are working with any product, you and your users are generating large volumes of data, even without knowing it. So, for instance, if you're working on an e-commerce platform, when you're scrolling through a particular list of products and you pause your scrolling to look at the details of a particular product, that is itself a data. How long did you stop to watch that product? How long did you take to look through the entire review section? Did you put it in your cart? Did you put it in your wish list? That tells the product and the product owners that you are interested in similar products, and then they can tune their entire system to recommend you better stuff. So that's how data science works. It's about data that is created, and we can assimilate that data. Even if large volumes of data exist, the larger volumes of data, the better. And then we extract information out of it. But what is the insight or the information that we extract is going to do for us? Well, data science allows you to make use of data you have available for you and then use it to gain insights that guide future decisions about a product or a company. Suppose you have some data available to you. You put it through a data science system, data science pipeline, and then you extract some information out of it. That information is there for you to take a look at and understand how you can better craft future decisions. So, for instance, the example that we discussed in which the sales prices might have dropped, you can understand that this could have a major impact on your company. Dropping sales prices means that people are losing interest in your products. Now, how can you fix that? You can go deeper into the trend and understand since when did the fall occur? What was the product that was released then? If we remove that product, what is the trend? And you can go back and forth with the data and understand how you can get a better understanding of how you can get your entire system and your entire profits back to where they were. So that's what data science does for you. It allows you to make better decisions. This is why data science is so important in many companies, because data science has helped in many companies to extract a good chunk of information and then guide their future decisions. Decisions backed by data is really important because they have a higher chance of working rather than decisions backed on intuition and no data. Now let's take a look at companies hiring data scientists. So as you can see, the companies that are hiring data scientists are quite varied. You have broadcasting companies such as BBC, to have and tech companies such as Google, Apple. You have e-commerce companies such as Best Buy. You have companies that are product based. You have companies that are service based. You have simple products as a company, and you have everything in between. The reason why this is important is because to show you how the entire ecosystem of data science has spread out into multiple companies. When we take a look at a list like this, it's very easy to just discard this as just being something for the tech companies and not for something that we want to use. When we take a look at the people who are interested in data scientists, even when we take a look at the analytics of our videos, we find out that people who are from mechanical backgrounds or telecom backgrounds or many other kinds of backgrounds, they are interested in data scientists. And if you are people who think that data science may or may not be important for me, I just work in the mechanical background, I just work in a telecom company, I don't work with these kinds of things, let me put your mind to ease, because these kinds of skills that we're discussing right now are really, really important. Data science can allow you to extract information out of mechanical background information or any kind of information. To give you a concrete example, if you're in telecom industry, suppose that you are having a base of customers. Those customers, you can create using data scientist a model which will tell you whether or not that customer may leave your platform or not. And if the case is that the probability of that customer leaving your platform is high, then you can incentivize them staying. You can lower the prices, you can give them coupons, give them products, give them some sort of reason for staying. So this is why data science is so important. Any field that has data, which in today's day and age is every field, even fields ranging from agriculture to medicine to real technical fields, all of them have data associated to them. And data science job is to get the data out of the scruffy little realms and figure out how you can use them to extract information and guide your future decisions. So that's how you can learn these things. Take a look at the skills that you need in order to become a data scientist. A quick note, these skills are not going to be extensive. We're not going to cover every single little skill in every bit of detail possible because that's not going to be possible. In case you wish for us to make more videos about that, please put it into the comment section below. And also like the video if you like our content and click on the subscribe button to never miss another update. Also click on the notification bell icon to be notified when we upload a new video. If you have any suggestions on what kind of videos we should tackle next, or if you have any queries regarding anything that we have covered, put them into the comment box below and we'll help you out there. Also in the chat box, please put your questions down. Any question that you might have, we'd be more than happy to help out. Let's take a look at the skills that are required. Now, data science is a really vast field, because of which a data scientist is expected to have a good grasp on multiple skills. So as you can see, data science is a multidisciplinary field. You need to know a lot of different technologies and need to know how they interact with each other. Let's take a look at the skills that you need in order to become a data scientist. The first skill is programming. It's not the only skill that you need, but you do need to know how to write code so that all the technical and complex calculations that need to be performed can be offloaded to machines that can do it very well. Computers are really great at doing calculations, and as human beings we are error prone. So when we input some numbers, if we enter something wrong, if we enter the wrong inputs, wrong operations, we get a completely different result. On the other hand, you can write code in which you can just ask the user to enter the numbers and the computation will be done by the powerful processors themselves. So this is why programming is important. Then comes mathematics. Mathematics forms the core of what we are trying to get at here. Data science uses mathematics and makes heavy use of different fields of mathematics. It doesn't necessarily mean that you need to know mathematics in depth and you need to be a mathematical expert, but you do need to know a little bit of mathematics in and have expert in these little bits of fields that data science expects you to know. Then there's working with data. As data science is a skill that needs for you to work with data, that means you need to have understanding of how you can deal with data that is incorrect, corrupted data, how you can take a look at data from multiple sources, combine them, and so on. And finally, there's deployment. Once you have built your data science model, you need to be able to help either the people who take care of deployment, or you need to be responsible for the deployment of the model yourself. Now, again, these are the skills that you need. There are many other skills that you might need also, but these are the core skills, core skills set that is expected from a data scientist. Now, let's discuss these fields one by one in more detail. So let's take a look at that. All right, guys. So let's take a look at programming languages that you need to know. Now, there are several languages that you can use in data science. As we have discussed, that data science is a multidisciplinary field. That means that you can have programming languages of multiple kinds and work with them when you're trying to build an application or build a data science pipeline. Now, two of the most popular languages that you can learn and have a great support for in data science is Python and R. Now, it's not necessarily the case that these are the only languages that you need to know. If you already know a programming language, chances are that there are libraries and ecosystems available for you to use in order to perform data science operations. So if you have been programming for a while and you already know C++ and Java, then you can use those languages because there are libraries available that make use of these languages and let you run code that can perform data science operations. However, if you are using languages such as JavaScript, maybe you're a new developer and you just started learning programming, you already have learned JavaScript because you wanted to learn web development, and now you want to leverage your existing skills. There are libraries available for that as well. There are libraries available for Ruby and Python and many other languages that you can use. But the reason why Python and R are so popular is because Python is a general purpose programming language. It can be used to do multiple things, and it is really easy to learn and understand. This is why many people like to get started with Python. And because of that ease of use and the popularity of the language, many people use Python for data science, and that's why it's the most popular general purpose programming language that can be used for data science. Then there's R. R is usually used in academic fields. If you're a research student and you are working on a research project where you're trying to use data science to prove certain hypotheses, R is really the kind of tool that you would want to use. Python, on the other hand, is a general purpose programming language, so it has support for features that are used in large scale software application development, such as object oriented programming and so on, which can be useful for data science as well. However, for R, there are no such things and you don't really need them. In R, what you're trying to do is write some code that will gain some data, perform some operations, provide some output, and you can either store that output in a file or display it in a visualization. So that is the reason why programming languages are important to be learned in a data science context. If you are a data scientist and you know a programming language, you can automate a lot of the heavy lifting and complicated tasks to a computer without you having to manually press buttons and do a lot of things. This is why programming is considered so fundamental to data science. And this is also why data science is a subfield of computer science and not a subfield of just science as a whole. Then comes mathematics. In case you have no understanding of how mathematics work and you don't have a really good grasp of mathematics, maybe you're poor at mathematics, do not worry. At the end of the presentation, we'll guide you through some of the resources. There are also videos available on our YouTube channel. You can check it out and understand how you can get started with either Python, R, or mathematics, or any of the technologies that we're covering. If you want a more in-depth look, we'll guide you through some of the resources through which you can learn these things at the end of the presentation. If you have any questions regarding anything that we have covered thus far, please put it into the comments section down below or into the chat box that's available. Our team is there to help you out our team is there to help you out with any query that you have. So please make use of that. Let's take a look at what kind of mathematics you need in order to learn these things. So there are several mathematical concepts that you as a data scientist need to know. Now, as a data scientist, there are certain mathematical concepts that you need to be familiar with. So let's take a look at those one by one. First one is linear algebra. If you've ever worked with linear algebra, you know that it deals with vectors and data as a table. How you can use data to describe data points in a field, how you can combine different points of data, how you can square them, multiply the matrices, and so on and so forth. This is why linear algebra is important. It is used to represent data in a mathematical and in a computer science context. Linear algebra is useful in computer science, in mathematics, in physics, and many other fields. It's important in data science because it allows us to represent our data in the form of either a single number or multiple numbers in a row, which is called a vector, or multiple numbers and multiple properties, which is rows and columns, which is called a matrix. Now these matrices could be two-dimensional, three-dimensional, so on and so forth. So it gives you a good basis of how you can gather data and then how you can manipulate that data yourself. This is why a linear algebra is so important. Then comes calculus. Calculus is mainly used in data science to basically reduce the error. It gives us certain functionalities and allows us to understand how moving in which direction in a three-dimensional plane would give us the least amount of error. Calculus is really useful in that regard. Now, calculus is also used for many other purposes in machine learning, in neural networks, and in many other tasks in data science also, but you need to have a good understanding of the basis of these concepts. You don't have to be a master in any of these. Then comes statistics. Statistics allow us to either discard or accept any hypothesis that has been created. So if you are trying to use data science in order to perform a research that you have gotten a grant for, statistics is something that you should know like the back of your hand. But if you are not someone who is familiar with statistics, you can learn these things pretty easily. Statistics is just science that deals with numbers and information. How you can use that to your advantage is how you are going to use it in data science. How you can get a sense of how spread out the data is, how you can get a sense of whether a variable is affecting other variables, and so on and so forth. And these kinds of insight lead you to build a better and better data science projects. So with that, let's take a look at working with data. This is another one of the essential skills that you need to know in order to become a data scientist. So there are several ways of working with data. Let's take a look at them one by one and get a good understanding of what they mean. The first one is data gathering. Data gathering, as the name suggests, is the process of gathering data from multiple sources. Now, it may not seem that important, but since data science is actually the science that deals with data, we need access to large volumes of data. Now, if you are working on a product that has been around for a while and you want to incorporate some data science practices in the development of the product, the problem there is that the data of that product, since it's been around for a while, is in different systems and it is of varying shape. So, for instance, when the project started, the people used to keep the data inside a file, CSV file or whatever. Then people started using spreadsheets. Then they started using databases. Then they started using on-premise servers for databases. Then they started using cloud databases, and now they're using containers. Now there are 6 different data sources here, and this is discounting all the data that has been generated by the users. They may be stored in different formats as well. And now in these 6 places, all of these data sources may have different shapes. So in some fields, new columns were added. In some data sources, some columns were dropped. The length of a particular column would have been changed. The relationship between 2 different columns in 2 different tables might have changed, and so on and so forth. So this represents a really clear distinction between just the simple act of getting all the data and putting it in one place to the actual process of gathering data in data science. And this is where everything comes into place. So you have to understand how to analyze the data first and then gather that data and then figure out how to best store that data if it's possible. So after gathering the data and understanding the differences between the different data sources, we analyze the data. Analysis basically involves for you to take a look at the data and figure out what is missing, what the data is lacking, how the data may not be suitable for you to use, and how you can fix it. So for instance, if you have a data source in which certain columns are not really filled. So for instance, you have a data file in which there information of 10,000 customers. Now, there's a column of age, but because the product only started asking for the age of customers very later on in its development stage, only a 10% of people have entered their age in the entire dataset. Other people have either left the platform or have not yet entered their age. That information is really sparse in your entire collection of data. Only 10% of the entire 10,000 people have given you that data, and maybe you can't use it. On the other hand, if it would have been the other way around and 90% people have given you the data but 10% haven't, what you can do is either drop the customers from the database that do not contain that information. That won't reduce your data to a significant degree. You can use certain strategies by either filling all the empty columns with 1, with 0, with the mean of the entire column, or so on and so forth. So there are several ways of dealing with this. Analyzing data also means that you take a look at outliers to figure out whether or not some data is extremely large or extremely small and doesn't make sense for your entire column. So for instance, if for the age column someone had filled -25, that means that that data is invalid. No person is going to be of the age -25. Similarly, if someone had entered 257, that was also a ridiculously large number, and you need to deal with that as well. That comes and other kinds of data comes with their own challenges as well, such as date fields from multiple time zones are collected, and everyone has their own way of writing dates. So for instance, somewhere people write months before the day, so somewhere people write days before the months, and so on. So you need to standardize all of that. To understand all of these problems, you need to firstly analyze the data. And then comes data visualization. After gathering the data, analyzing the data, fixing the data, that comes visualization. Visualization is really important when you're trying to learn new things about the data, especially if the data set is large. We as human beings have only so much brain capacity. We can't keep into our heads a long list of data, especially if the list of data is so varying. And even if we can keep the list of data in our head, we can't make heads or tails of it. On the other hand, if we were to visualize it, We can understand the trends of the data, what kind of data is dominant in the entire collection, what kind of data is not so dominant in our entire collection, and what can that tell us. Visualization also helps non-technical people to make sense of the data that we have. So if I create a pie chart of three of the products, and one of the slices of pies in the pie chart is really large, that automatically makes them understand that one of the products that has the color being representing it will give is the product that is being used by majority of people, and other two are really in minority. So that's why visualization is so important. Visualization also helps us in order to extract useful information out of it, and then use that information to further our goal of extracting insights. Then comes data modeling. If you've ever heard of data modeling, you may have heard of things such as creating a machine learning model, creating a data science model, and that's exactly what data modeling is. Modeling basically means that you take the data that is available for you and you create a model out of it. A model is a system that has an understanding of the data that you have. So it extracts knowledge out of that data and can then make either predictions or can perform classifications. So imagine you have a lot of data of images. Your customers like taking a lot of images. You are an image platform. Now what you want to do is you want to create a platform in which when people take their photos and upload it, they are automatically tagged. This is the feature that was implemented by Facebook. So if you are a person who wants to just click a photo, upload it on the internet, and you want the platform to just tag all the friends that appear in that photo automatically, you can do so on Facebook. Now to create that, you need access to a lot of image data. You need access to a really good computer system that can take care of processing that image data. And then you can model a particular system on that data and then create certain rules and figure out how you can tag people and identify people and then tag them in a photo. Now, this is a really oversimplified view of what is happening underneath the hood. It's very, very complicated because it's a really complicated task to perform. However, after performing those tasks, these are the basic steps. So this is what things that you need to understand when you're handling data. You need to be able to gather the data, analyze the data, visualize the data, and modeling the data. Now, again, these tasks seem ginormous and really difficult to understand. Many people quit at these points because they think that it's really difficult for them to learn and they would have no use of it. Again, data science is used in all fields, so you can take a look at the skills that you need and you can use these skills one by one. You don't need to be an expert in all of those to make any meaningful changes. After that, after learning these things, you also need to learn deployment. So there are several ways of deploying a model. Deployment basically means you make your model available for public use. If I'm trying to create a machine learning model, I want that model to be able to use in real world. So for in real world, for example, if I have created a model of data science using data science techniques, using gathering a lot of data, and I deploy that to the real world, now what I want is for people to send some information to it and it will return back a response. So for instance, what it can do is that it can gain some information about the last 5 days of temperature and the geographical location, which is the latitude and the longitude of your place. And what it can do is then calculate the temperatures for the next 5 days and return that information to you. So you can deploy it using two ways. First is cloud deployment. Many cloud service providers such as Amazon Web Services, Google Cloud Platform, and Microsoft Azure have their own systems for creating machine learning models which can be deployed with a single click. AWS, for example, has AWS SageMaker, and there are many other platforms available as well. These are the only ones that we are mentioning, but these are not the only ones that are available. So you can use those. Google makes extensive use of its cloud platform in order to leverage high computing capabilities and deploy models that can perform really complicated tasks. On the other hand, if you don't want to use cloud deployments, then you can create a REST API deployment. In case you're not aware of what these two things are and how they work, don't worry, we'll guide you through the resources. Just stick with us till the end. So here, what we do is we have a REST API, and that REST API is going to accept some data and then return some response using the model underneath the hood. Now, the thing here to understand is that these REST APIs are managed by us. In cloud deployment, we don't have that level of granular control because it is managed by the cloud environment. So we don't have access to the internal working systems and we don't change these things. On the other hand, we have extreme level of access in the REST API deployment. We can deploy it on our own servers. We can deploy it on any server we choose to, and we can configure it however we wish to. But because of that high level of control, that means anything that goes wrong is going to be on us to solve. If you're not very familiar with server management, if you're not very familiar with taking care of a large farms of servers or a single server, but taking care of how it works and starting it up when it goes down, cloud deployment may be a better option. But if you want higher levels of control, then maybe REST API deployment is for you. Now let's take a look at a learning path. So the learning path goes like this. If you're trying to gain the data science skills that we have discussed, if you are completely unskilled and you have no idea how to get started, this is the learning path that we would recommend. Firstly, learn programming. Any programming language would do. We do recommend that if you have not learned a programming language or are looking for a challenge, learn Python. Python is by far the best programming language for data science, especially if you want to move on from data science to other fields in future, because Python is so multidisciplinary. After learning programming, and you don't have to be an expert, you just need to learn the basics of how you can write a simple script that can automate a few things in your entire system, and you can use that. Also, we have to learn mathematics. You can learn programming and mathematics side by side. So that would help you understand how you can implement the mathematical concept that you have learned in a particular file of code, and then you can use that. Thirdly, you have to learn building projects. Now, the other skills that we had discussed, these are the skills that you learn while building projects. So while you're building a project, you gain access to some data. After gathering that data, you can get the data of some websites as well, such as Kaggle or UCI machine learning platform or many others. After gaining access to the data, then you clean it, you analyze it, visualize it, modify it, and create a model out of it. You can also participate in hackathons that are arranged by online competitive platforms such as Kaggle or HackerEarth or many other kinds of platforms, in which you can show off your skills of data science and you can gain prizes and experience. Finally, getting certified is really important. Once you get certified, because there are so many people out there who are looking for a data science job, you getting certified means that you actually have a certificate that can tell the employee or the employer that you have the necessary skills needed to become a data scientist. These certifications are only given out to people who have actually passed a test, and that test is really rigorous, that tests them on their skills. If they possess the skills, then they are given that certificate, and that helps them stand out of the crowd that has applied for a particular position. After that, you are free to apply for the jobs. Now, these are the kinds of things that you would have to learn on your own. However, these are really important to understand. So how do you learn these things? How do you go about learning these technologies? How do you go about reading about these things, and how you can go about assimilating all of these technologies and topics that we have learned thus far and get certified on those? This is going to be what we're going to cover next. By then, thank you so much for joining us, and we hope this has been fruitful. Now we'd like you to learn how you can learn these things. We hope you have subscribed to the channel and clicked on the notification bell icon. If not, then please do so. Click on the like button on the YouTube video if you liked the content that we have produced, and if you have any questions, put them into the question box or put them into the comment box. If you want access to this PPT, then you can put it into the comment box down below, and our team will reach you out and help you out with gaining access to it. With that, thank you so much for joining us, and now we'd like to show you how you can learn these things.